Good evening, everyone. Welcome back to another project presentation by 360DigiTMG. Myself, Swati. Today, me and my team are going to give a presentation on facial login system with liveliness detection. So, how interesting and convenient it will be if we can log into the LMS with just a click. So, this project is all about facial login system for the LMS purpose. Title itself, facial login system with liveliness detection. In this project, we have built a facial lock system. Before building a face lock, there were some main concepts involved in it, like there were face detection, liveliness detection, and face recognition, through which we can get our LMS access. So further in the following presentation, we'll be discussing all about the technical part and what all we did in this project. And moving on to the next slide, please. Yes. Upon completing this project, me and my team would like to express our sincere thanks towards our mentors, Mr. Sharat, Aditya, and Gomati. They had given us, me and my team, unconditional support throughout the project. Sharat and Aditya had not only solved many of our encountered problems, but also being very concerned about a project by giving us a lot of alternative options during dealing with this project. Thank you very much for assisting us throughout this project. We sincerely thank 360DigiTMG for providing this opportunity. Next slide, please. Following are the team members who have worked on this project: Dinesh, Srivani, Abhishek, Sriram, Swati, Ricky. Next slide, please. Yeah, these are the following contents which in further we'll be discussing: project goal and scope, CRISP-MLO methodology, project introduction, project schema, project description, project architect, data collection, technical stats, system requirements, model building and description, deployment strategy, output for the deployed model, benchmark, pros and cons, conclusions, and future scope. And finally, we'll have a QA session. Next slide, please. Project goal and scope. Yes. Sorry. Yeah. So firstly, project goal. Build a model for facial login, then a person is real or spoof, and then moving on to the grant access. Those are the main of the three parts of the goals. And here comes to the objectives. Build a facial login, have enough memory space to store the database, able to recognize the face of an individual accurately based on the face database, provide a user-friendly interface for access, able to show an indication to the user whether the face recognition process is successful or not. And coming on to the constraints, how much it's possible we can minimize the spoofing and restricts the unauthorized person also. And coming on to the scope, in this project, an application is already developed, which is capable of recognizing the identity of each individuals and eventually recording down the data into the database system. Next slide, please. Yes. And this is something called as very important in our project, that is CRISP-ML methodology. Now we are going to talk about the CRISP-ML, that is cross-industry standard process for machine learning. It is a systematic process model for machine learning software development. It creates awareness of possible risks and quality assurance to diminish the risk to ensure that machine learning projects get success. It's a framework with the help of we can build a model. We would meet the customer requirement. It involves 6 necessary steps as shown in the following figure. The first step is business and data understanding. So what's the client's requirement and desired output? Data understanding, here we have to know what type of data we should involve in a database to create a model. Next step, data processing, data engineering. That's data preparation, data pre-processing, data cleaning, and EDA part. What type of data we would require for a model? We could prepare a short listing that required features from the list of all the features and perform basic EDA on the following data, so that data will be used to build a perfect model. Third step, model building. It can be either supervised or unsupervised or some reinforcement. That's what ML algorithms. Here we need to select the modeling technique that we will build on our requirement of model. And then moving on to the model testing and model evolution. So here model evolution is subscribing part of model deployment process. It is the phase that is decided whether the model performs better. Therefore, it is critical to consider the model outcome according to every possible evolution method. Here, applying different methods can provide different perspectives. And the fifth step is model deployment. In this stage, we have to make a model live for our customers where they can use it as per their requirements. And also we should get the feedback for the customer satisfaction, and work on continuous service improvements on a future scope. Sixth step, monitoring and maintenance. Here, the maintenance phase happens after the project team deploys the software and it's fully operational in the customer environment. During the maintenance phase, the customer monitors the software to ensure it continues to operate according to the coding specifications. Here we go. That's what the CRISP-MLO methodology is important for any of the projects. And moving on to the next slide. Now coming to the project introduction. As in the beginning, we have discussed that face detection, liveliness detection, and face recognition is something which gives us access. So firstly, that was the main intro. Now getting into the main concept, before we should know about some basics. And that's what's a face. The face recognition is a step to face detection. In face detection, we only detect the location of the human face in an image. But in face recognition, we can make system identify humans. And then there are several methods to perform facial recognition depending upon the performance and complexity. Before getting into the project, few things, like as I said the two modes of face recognition. There are traditional face recognition algorithm and deep learning for face recognition. We have used deep learning. Some of the widely used deep learning based face recognition systems are Deep Face, Deep ID, series of systems, VGG Face, and FaceNet. And then now, as I said, these were the basic concepts before getting into now the main intro part. The technology working behind will be the face recognition system for this project. The human face is one of the natural traits that can uniquely identify an individual. Therefore, it's used to trace identity as possible for face to deviate or being duplicated is low. In this project, face database will be created to pump data into the recognizer algorithm. Then during the LMS access session, face will be compared against the database to seek for the identity. When an individual is identified, its access will be given to the particular person automatically, saving the necessary information into the database. At the end of finally, what I want to mention is that information regarding an individual can be accessed from web-based server hosted by the FAST API. And then as the two main parts already mentioned in the following screen is user registration and user login. So user registration is something where the forms are or the profile pages that request information for a user to create a web-based account. And login is something, as already we have discussed, the data which is saved in the system by getting back to the checking the details, it will give an automatic login permission. That's what from here one of my friend, the teammate Abhishek will take over. Thank you.
Thank you, Swati. Good evening, all. This is Abhishek. Here I will present you the brief overview of this project. In the first step of webcam captures the frame and detects the face. Next, it passes through the liveness algorithm to verify whether the face captured is genuine or fake. On verifying the authenticity of the frame, it is then passed on to the face recognition model where the embeddings of the detected face is matched in the database. On successful verification, access to LMS is granted. Next slide. In this slide, I'll explain you the working of the face verification system. It involves 4 steps: face detection, face alignment, face extraction, and face recognition. The first step in the face verification process is the face detection. Face detection is the process of automatically locating human faces in the visual media, that is both digital images and videos. Faces are determined using landmarks such as eyes, mouth, and nose. The next step involves face alignment, otherwise also known as normalization. The detected faces are aligned using translation, rotation, and scaling. This is done so as to improve the model accuracy. In the next step, the detected face is passed through a pre-trained face recognizer that is capable of handling 128 dimension embeddings. This embeddings is then compared to the database of known face embeddings to give you the identity of the person. Next slide. In this slide, I'll explain you briefly about the liveness detection and its architecture. Liveness detection is a technique where an algorithm securely detects whether the source of a biometric sample comes from a fake representation or is a live human being. There are 2 main types of liveness detection: active and passive. In active, the model prompts the user to perform a specific action and then carry out the live verification. whether passive detection, whereas passive detection uses algorithms to detect a non-live image without user interaction. In our project, we utilize the passive detection. Next slide. Here you can see a typical architecture of a passive liveness model. Faces are first passed through a face detector, where it's resized and fed into the liveness model, which predicts whether the image is genuine or spoof. Next slide. Now let's look at the project architecture. The frame is captured by the webcam and sent to the face detector, which detects the face using the OpenCV's deep neural network single shot multi-box detection, or commonly called as SSD. The detected face is then resized and fed into the liveness model. The liveness model used in our project was trained on EfficientNet Lite 4 architecture using the TensorFlow Lite platform. On authentication of the face, the frame is then sent to the face recognition model. For face recognition, we use the deep face recognition system, which is a hybrid face recognition framework that incorporates all popular face recognition models such as FaceNet, OpenFace, DeepID, ArcFace, DLib, and VGGFace. The particular model used for this project was VGGFace. And finally, in the deployment part, we use the Fast API web framework, which incorporates the entire login management system. Next slide, please. In this slide, I'll explain you the data collection methodology. For training our liveness model, we collected images of our project participants and several copyright-free stock images. It was ensured that the dataset collected consisted of people of diverse ethnic backgrounds and skin tones and under different lighting conditions. The presentation attack dataset consisted of printed photos of participants and stock images, as well as screen video replay from mobile phones and tablets. In total, we collected over 22,300 images for training this model. That is all from my side. I request my teammate Shivani to take it from here.
Thanks, Abhishek. And from here, we will move on to discuss on the technical stacks. So we have used the following technologies to build and run this project. The following technologies are Python, Keras. As we know, Keras, which is very simple and flexible, too powerful to utilize, and which computes the gradients too. And the OpenCV is most commonly used in this project for real-time computer vision models. And we have used Google Colab for running and testing the liveliness model, which is nothing but efficient NetLite model. And the Spider is an as you all know, it is an integrated development environment which is used for scientific programming and AI models. And the framework models which we used here for face liveliness detection for detection is face detection is Cafe model. We prefer this Cafe model due to it has fast accurate detection using a pre-trained deep learning face detection model. And this model contains two parameters. One is prototext file and the Cafe model file. The prototext file actually explains us the model architecture, and the Cafe model which contains the weight of the actual layers. And we have used for face authentication another library called DeepFace, which is widely used for facial recognition with multiple packages of wrapping up. Includes several face recognition models such as VGGFace, FaceNet, Google, DeepFace, OpenFace, ArcFace, DLib. And we have one more technology used at the backend level is SQLite. We have preferred the SQLite, which is lightweight and disk-based database, does not require any separate installation of the any server. It supports all the DB functionalities, and the front-end technologies are HTML and CSS for the web design part. Moving on to next slide. Yeah, here we go with the system requirements. The system requirements we tested with the minimum memory of 4 GB RAM, and it could be more than it. And CPU we have tested on Intel Core i3 is the basic one, and it can also be tested on GPU based systems. And the OS we have used is Windows 10, and it could be more than that. And the Python we preferred is Python 3.7 version. In the right section, we have seen the couple of packages which were used inside this model. Deep Face Library and TF-Lite Model Maker, TensorFlow Library, NumPy Library, CV2, SK Image, RE, and Fast API. Deep Face Library is the most widely used for face recognition model, and TF-Lite Model Maker is we have used since it is stronger in the using of transfer learning, and which reduces the amount of training data, and also it shortens our training data time. And the SK Image, which we used for image processing and computer vision algorithm, RE is a regular expression package which matches the operations during the deep face learning methods. Fast API we have used for the lightweight deployment process in this project. Moving on to next slide. Yeah, here we talk about the model building and its description. So this model is actually built upon two methodologies. One is for registration and another one is login process. For registration, we have used two following methods. One is face detection and another one is face liveliness. And for login process, we have to go through three processes. One is face detection, face liveliness, and face authentication. And first of all, we'll describe about what is face detection, how do we use. To detect the face, we have utilized OpenCV to detect the frontal face detection, and the liveliness model, which evaluates the frames of the images or video. After this DNN model detects the person's face. And for liveliness, next, once we capture the frames or images from the video, and we will be passing on the image to face liveliness model, which is nothing but efficient net light model. And this efficient net light models are actually mobile friendly or IoT friendly image classification models, which scales uniformly in the depth wise, width wise, and the resolution wise with a fixed set of scaling coefficients on compared to the other models. In any case, if even if you do not crop the image, and if your input image is bigger also, this efficient net light have the flexibility to use more layers to capture the more fine-grained patterns and the features. So this we preferred. Basically, this model runs on the TensorFlow Lite model, which achieves higher accuracy on compared to the ResNet model, MobileNet version 2, and Inception v4. This efficient net light model runs inferences in a real time greater than or equal to 30 FPS frames per second. And the another part, the above one, whichever we described, used for registration. While the webcam video, we used to take the live images of a person. But in order to perform the login methodology, we need to go with another additional process is called face authentication. Here we have performed face authentication in the form of two models. Model 1, the deep face library is used with using cosine similarity to authenticate the person, and the model 2 describes about the Euclidean distance to authenticate the person. So basically, this face authentication is used to authorize the person whether he is the real person or he is being registered. If he is not being registered, then it will this model will tell us it is a spoof image. Please log in into, please subscribe it, please register in the LMS system. So we have used two distances. As we all know, cosine similarity, which actually identifies the angular distance between the images, and the Euclidean distance is actually identifies the distance between the differences of the distance between the vectors. Using these distances, it actually compares the liveliness images with the database of LMS database system. Moving on to next slide. We'll move on to code snippet part. So here we see, as we discussed in the previous slide, face detection. First, we will go with the face detection. So we have used CV2 to recognize the capture the frames, and once CVT capture the frames, we have read this cafe model, which contains two parameters, deployed.prototext file and .cafe model file. And this video stream, once it starts, this stream actually captures by setting this parameter 640/480 size, and we read the once the frames are read from the video live webcam, and we capture the blob from an input image, and we set the blob into blob of the faces in the image. And once the faces is being captured, and we as we discussed earlier, we have used efficient net light model, and this model we will pass the loaded frame into this model to predict the person is live or real or spoof. So in order to predict, actually we loop through these detections. Through these detections, we will find the cropped image. We will find the cropped image, and this image is passed on to the prediction model. This prediction model determines the score. If the score is greater than, this prediction model gives us the resultant score of 0.6. If it is greater than 0.6, and this model will tell this person is the live and he is the real person. And if it is less than 0.6, it says, this model says he is a spoof image, and it could be any print attack or any spoof images could be detected. So once the real or spoof image is determined by the model, and we have printed on the top of the image on around the boundary box. And we have one more process, as we discussed, used for login purpose, face authentication. Here we see deepface.find method actually passes the live image in the image underscore path, and in DB part we have the LMS access database contains the images, and this real image is actually finds against all the database containing images using the Euclidean distance or the cosine similarity. Yeah, moving on to next slide. Here we see we have the liveness model accuracy. And to determine the accuracy, we have used here is confusion matrix, and which helps us to evaluate the performance of the model. And also for the model management purpose, we have mainly used this confusion matrix. Confusion matrix basically compares the true values with the predicted values of the model. This is actually important concept of the model for model evaluation, and how this model performs could be determined using this confusion matrix. As we all know, the true positives which correctly predicts the positive classes, which are 36 are represented here, and the true negatives are predicted. True negative classes over here is 59. True positives are 36, and the true negatives are 59. And the false positive, which is nothing but called type 1 error, where the model incorrectly predicts the positive class when it is actually negative but incorrectly predicts, which could be 0.19. And the false negatives or type 2 error, which incorrectly predicts the negative classes, actually 4.1, which is very less amount of determination in false positive and the false negative, whereas we have seen huge prediction over true positive and the true negative. And we will go with the some part of metrics here. Confusion matrix metrics. Accuracy, whereas the prediction of the model classified here 95.6%, and the prediction positively predicted accuracy here 99.47%, and the recall which we used here, the true positive rate, gives us 89.8%. In this way, we can determine how our model is working and what is the performance of the model we have determined using this help of the given metrics. Moving on to next slide. Yeah. Here, slide explains us what is the training and validation accuracy and how it behaves, and what is the training and validation losses. This training loss actually tells us how model is basically fitting into our training data. And the validation loss indicates how well the model fits new data when it comes to new data. And we have checked the training and validation accuracy of the model, which shows the important significant improvement in the accuracy. And the blue line is for the training part and the orange line is for the validation part. The model was actually run for 5 epochs, and the training accuracy came to be around 98.31, and the validation accuracy came around 99.77. And we have seen in the last point of view, always for any perfect model, for any idealistic model, accuracy should be more and the loss should be less. Here we see the same happen. So the training loss is actually decreased from 0.302 down to about 0.255, and the validation loss is also decreased from 0.235 to 0.244, and the loss for both was decremental in the nature. This way we cannot see here any overfitting and underfitting in this part, so that we can tell our model is well fitted model we can utilize for the face liveliness detection. Yeah. From here, passing on to my colleague Dinesh. Over to you, Dinesh.
Thank you, Shivani, and good evening, everyone. So now we are at model deployment stage. So for the model deployment, we have many web frameworks like Web2Py, Django, Flask, Fast API, and many more. Out of all these, we have adopted Fast API, which is one of the most widely used and high performance framework for the deployment process. It has very much exciting features. It is easy to learn, code fast, it has simple syntax, and as the name suggests, it is blazing fast framework. It is ready for deployment based on Pydantic and Starlet. Pydantic, it is a library that provides runtime checking and validation of information that relies on the input that is being passed, which is basically a data validation and settings management. Coming to Starlet, Starlet is a lightweight, low complexity STT web framework, which is integrated in Fast API. Fast API also has validation of string query parameters, validation of numerical parameters. It has better error handling and custom messages when compared to other web frameworks. It automatically generates open API documents. And at last, it has Swagger UI. Swagger UI, it is interactive exploration. It calls and tests the API directly from the browser. Fast API converts configurations to JSON file or format to make them compatible with Swagger UI. Swagger UI is visualization and interaction API resource without having any implementation logic in place, which is visually we can see the documentation and making it easy for backend implementation and as well as client-side consumption. Now coming to facial login implementation approach, we will understand how we have implemented the facial login system. So broadly, we have two parts to this, registration and login. Firstly, we'll understand the registration process. Registering process captures the user image within 5 seconds and saves it into the database in encrypted format. Once the user is registered, we need to follow two frameworks or methodology for the login process. We have traditional login, that is logging in using user credentials, which is password and email ID and password. And secondly, we have facial login. Facial login is another approach which is widely used for facial recognition technology, and many organizations and are implementing this facial login and many devices also for ease of access to any LMS platform. Once the user clicks on facial login, webcam starts checking liveliness and recognizes the human face, considering the number of facial aspects and landmarks like reading the eyes, nose, lips, jawlines, and many others. It verifies or authenticates with the register image that we have registered earlier or the user registered earlier, and grants access if the user is authenticated. The model is deployed using fast API web framework and templates. It uses web pages are designed based on the HTML and CSS. Now we are at the page of user registration. This is the output that we have developed. And we have given instruction to be followed before registration. The user needs to give his or her name, email address, and password to register. The user also needs to understand and follow the requirements, that is good lighting conditions, face should be straight to the camera, and facial position should be at a distance of around 30 to 55 cm. Now moving on to login page. We have two methods of login as we discussed earlier. One is traditional login and facial login. A traditional way of implementing login process is by entering username and password. It authenticates and authorizes the user's data that is being saved or encrypted and takes you to the dashboard page of the respective login in user. If a user wants to get with the traditional login, the demo which will be explained in the output, how it is being done. And if someone wants to go with the facial login, that is which is easy and convenient, they can click on the facial login button. The instructions should be followed, which are similar to the registration process. The model will check the liveness of the user, and once the user's face is authenticated, access will granted to the LMS dashboard. Let's have a look on the video. This is print attack using multiple faces. Access denied and trying logging again. Print attack using unregistered person's face. Access denied. Print attack using a celebrity face. It is identifying as spoof. Trying to log in without registration. Unauthorized access. Now we'll do the registration. Once we click on register, the image will be captured and viewed to the user. User registered successfully. Now we'll check with the incorrect credentials or unregistered email ID. User not registered. It is the error. We are trying to log in using incorrect password. It will show error incorrect password. Now we'll check by giving the correct credentials. And access granted to the LMS dashboard. We'll check now with the print attack of the registered person's face. It is saying try logging in again. Now we'll check with the photo attack with the registered person's face. Access denied. Replay attack with the registered person's face. It is a video that is being played. Access denied. If the user's face is slightly mismatched, then it will not allow. It is access denied. Now the face is placed properly in front of the camera and access is granted to the dashboard. Now we are at the benchmark slide. Here we have tested the model with the least configuration system available with us to set a benchmark and understand the performance of the model. Along with this, we have tested the model with various other systems having different configurations, that is processor and different camera resolution, and under various lighting conditions. And we tested it under various facial conditions, that is front face, side face, background light, a person wearing spectacles, facial hair, occlusion, spoof images, replay videos, near and far positions. So after testing, we found that 30 to 55 cm is the ideal position which the model identifies the face and grants access to the LMS. Now we'll understand the trade-offs of the two models. As Shivani discussed, for the facial authentication, we used two models, that is model 1 and model 2. Model 1 uses cosine-based similarity for facial authentication. The accuracy of this model is better, which is around 99.12, and the latency is around 2 to 4 minutes based on the system configuration and multiple tasks running in the system. The registration and login can be under different visible condition, lighting condition, and slightly different facial orientation, but it will access only the straight frontal faces. Model 2 uses Euclidean distance, which is basically the distance of the landmarks, which identifies from the register, and while trying to log in, it maps the landmarks, and it is basically the distance. And if it is matched, then the facial authentication model does the facial authentication and grants access. The accuracy of this model is slightly inferior than the model 1, which has accuracy around 53.5%, and the latency is around 2 to 10 seconds. The response time, it is based on the system configuration and multiple tasks running in the system. The response time is quite better than the model 1. The registration and login should be under similar condition in this model, and under similar visible lighting condition, and maybe slightly different facial orientation. But the face should be frontal faces. The model detects frontal faces when user is placed in front of the camera. Now I would like to hand over to Ricky to continue further.
Thank you, Dinesh. So good evening all, this is Ricky. So now let us look into the pros and cons of this model. A traditional face recognition technology is not all perfect yet. It has both pros and cons. So coming to pros, contactless biometric identification, as the authentication here is done using face recognition. It is compatible with most of the laptop cameras ranging from 0.2 megapixel to 20 megapixel. The ease of integration, and also can recognize person with or without glasses. Coming to cons, it cannot discriminate between twins, and also it doesn't perform very well in poor lighting conditions. As this model is built using a combination of multiple models, it requires a GPU-based system to run faster and efficiently. And also it lacks extensive testing. Next slide. So coming to the conclusion of this model. So this model has broadly 3 parts in sequence, that is face detection, liveliness detection, and face authentication. For the registration part, face detection and liveliness detection works. And for the login part, face detection, liveliness detection along with face authentication works. So while building this model, the liveliness detection was one of the challenging part which required rigorous training and testing. Various AI models were tried and tested for this project, and finally we resorted to OpenCV DNN, TensorFlow Lite, and DeepFace. The reason being these models were found to be efficient, effective with less memory usage, and are easier to implementation. Now let's look into the future scope of this model. Further, this model can be made mobile compatible, and also like multiple logins can be done simultaneously, that is concurrent logins can be made. Coming to the scalability of model, scalability is nothing but productionizing the model. For further production, the model can be done using a cloud platform or a distributed environment like Hadoop, etc. And also we can reduce the latency. That is, here currently it is 2 to 10 seconds. We can reduce the login time. Further, we can also validate with the help of email ID. That is, for example, like sending an OTP to the email in order to authenticate it. Next slide. So now if you guys have any doubts or queries with respect to this presentation, feel free to post your queries in the chat box. I think all your queries have been answered in the YouTube live. So I would like to thank 360DigiTMG and InnoDataTix for this opportunity, and also would like to thank all my fellow teammates for putting in a great effort, and also like thank you everyone for joining with us. Thank you all.